Okay, Wildcat, today we're looking at Wednesday, March 27th, solve exponential equations on page 64. If you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at the notes. Solving exponentials by graphing and same base on page 64. Ways to solve exponential equations. The first way is get same bases. Step 1, rewrite each side with the same base. Step 2, since the bases are the same, the exponents are equal. Step 3, solve the equation for x. Now at this point, you have three different paths. Okay, path 1, if it's linear, step 4 will be variables on one side equal the number on the other side and solve. If it's quadratic, step 4 will be set the equation to ax squared plus bx plus c equals 0. Step 5, factor use the quadratic formula. Step 6, set each factor equal to 0 and solve. Now, if there's 4 terms, you factor by grouping for step 4, and step 5 would be set each factor equal to 0 and solve. Okay? All right. Next, the second way would be solving by graphing. Step 1, graph the right side. Step 2, graph the left side. Step 3, find the intersection. And then the third way, which we're not going to get into yet, is solving using logarithms. All right, if you would, update your notes. Now your notes are updated. Let's take a look at our examples, which are on page 64. All right, now solve each equation by graphing. Okay, so step 1 would be graph the right side. So I'm going to do this in color. So I'm going to graph the right side in green, or in orange, and the left side in green. All right, so the right side is very simple. It's a horizontal line at 4. So 1, 2, 3, 4. Okay, now the left side, we need to find values. Now I'm going to start with, let's let x equal 0. So when x equals 0, you have 3 to the 0 plus 1. Well, any number to the 0 is 1, so 1 plus 1 is 2. So your first point is 0, 2. Okay, and then let's try x equals 1. So 3 to the 1 plus 1. Well, 3 to the 1 is 3 plus 1 is 4. So you have, next is 1, 1, 2, 3, 4. You notice at that point, these graphs are going to intersect, so that's your solution. Okay. Now also, you notice that you have an asymptote and that asymptote occurs at this number 1. Okay, so your curve for the left side is here. So when x is 1, f1 of x is 4, and f2 of x is 4. So you can see here that they have the same f of x value at 4, so your solution is x equals 1. Okay, so finish up example 1. All right, let's take a look at example 2. Okay, so we graph the right side, which is a horizontal line at 1. And then we're going to graph the left side. Now, I think that the best value to start with would be when x is -1, because -1 plus 1 is 0. Okay, And notice here I started when x is 0. So when x is negative 1, that's 4 to the negative 1 plus 1. Well, that's 4 to the 0, which equals 1. So at negative 1, you see here that they intersect. Okay, we know we have an asymptote at 0 because there's no vertical transformation. We know for exponentials, our curve is like this. All right, so you can see here when x is negative 1, f1 of x is 1, and f2 of x is 1. And what I mean by f1 of x, this is f1 of x. It's the first equation and second equation when you're graphing left and right side. Okay, so you can see here our solution is x equals negative 1. All right, go ahead and finish up example 2. All right, let's take a look at example 3. All right, so we graph the right side, which is a horizontal line at 1. Okay, now we graph the left side. Now here, looks like I want to start at x equals 1 because 1 minus 1 is 0. So x equals 1. That's 2 to the 1 minus 1 minus 3. Well, that becomes 2 to the 0 power, which is 1. 1 minus 3 is negative 2. So your first point is at 1, negative 2. Okay, now let's try when x is 2. So it's 2 to the 2 minus 1 minus 3. Well, that's 2 to the first power, which is 2. 2 minus 3 is negative 1. So your next point is 2, negative 1. And then let's do x equals 3. So that's 2 to the 3 minus 1 minus 3. Well, that's 4 minus 3, which is 1. So your point is x is 3, 1. You see here, they intersect, so that's going to be your solution. Our asymptote is at negative 3. So negative 1, negative 2, negative 3. And we know our exponential curve is this. So you can see here at when x is 3, or I'm sorry, when x is 3, f1 of x is 1, and f2 of x is 1. So our solution is x equals 3. Okay, let's take a look at example 4. All right, so we graph the right side. So that's a horizontal line at 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now we graph the left side. Now, like I said, I like to start when x is 0. So negative 1 plus 1 is 0. So I'm going to start with x equals negative 1. So 2 to the negative 1 plus 3 equals, well, that's 2 to the 0 power. It's 1, 1 plus 3 is 4. And I take it back. Yep, no, that's right. X equals negative 1 is 4. So negative 1, 1, 2, 3, 4. Now, x equals 0. So 2 to the 0 plus 1 plus 3. That's 2 to the first power. 2 plus 3 is 5, so your next point is 0, 5. Okay, and x equals 1. So that's 2 to the 1 plus 1 plus 3. So that's 4 plus 3 is 7. So 1, 1, 2, 3, 4, 5, 6, 7. And then when x equals 2, that's 2 to the 2 plus 1 plus 3. Well, that's 2 to the third power is 8 plus 3 is 11. So when x is 2, it's 11. Now your asymptote occurs at 3. So 1, 2, 3. So our exponential curve for the left side is this. All right, so you can see when x is 2, f1 of x is 11, and f2 of x is 11. So your solution is x equals 2. All right, go ahead and finish up example 4. All right, so now let's take a look at example 5. Now we're solving algebraically, so we're looking at getting the same base, okay? Now, what you might do before you get started is turn your page, and let's take some time in the video to add some lines just to help keep our work organized. All right. Now here we want same base, okay? So the way you have to think about this is we can write 9 as 3 squared. Okay. Now here we have to think, is there a way to write 27 with a base of 3? There is. That's 3 to the third power. Okay. Now, when the bases are the same, the exponents are equal. So since the bases are 3, we can say that 2 times 8 minus, I'm going to put a 1x, is equivalent to 3 times 1x minus 3. Okay, now it looks like we have linear, so we're going to need to simplify and put the x's on the left side, the numbers on the right. So 2 times 8 minus 1x is 16 minus 2x equals 3x minus 9. We're going to add 2x to both sides, and we're going to add 9 to both sides. So this cancels, you're left with 25 equal to 5x. So you divide 5 by both sides, so x equals 5. Okay, let's take a look at example 6. So again, we want the same base. So I see a base of 2 here, and I'm thinking, well, is there a way to write 8 with a base of 2? There is. 2 to the third power is 8. Okay, now the bases are the same, so the exponents are equivalent. So we can now say 3x is equivalent to 1x plus 6. Well, we can subtract 1x from both sides, so 2x equals 6. Divide 2 by both sides, so x equals 3. All right, let's take a look at example 7. So here we see a base of 2, and we think, is there a way to write 2 or 1 divided by 64 with a base of 2? Well, there is. Well, 2 to the negative 6 is equivalent to 1 divided by 2 to the 6th power, which is equivalent to 1 divided by 64. Okay, so we can say that 2 to the x minus 1 is equivalent to 2 to the negative 6th power. The bases are the same, so we can set the exponents equal to each other. So x minus 1 equals negative 6. Add 1 to both sides, x equals negative 5. Okay. All right. Example 8. Save the best for last. Okay. Now here we can see that the bases are both 5, so the exponents are equal to each other. So we can say that 1x cubed plus 4x squared is equal to 9x plus 36. Now, it looks like we're going to have 4 terms. Oh, we need to move everything to the left side and set it equal to 0. So we're going to subtract 9x and subtract 36 from both sides. So we have 1x cubed plus 4x squared minus 9x minus 36 equal to 0. Now, there's 4 terms, so we're going to factor by grouping. It looks like we can factor out an x squared from each of the terms. So 1x squared, which would leave x plus 4. Now, it looks like we can factor out a negative 9 from both of these terms. So that's minus 9, which leaves x plus 4 equal to 0. Since these two terms are the same, we can factor by grouping. So we have x squared minus 9 times x plus 4 equal to 0. Well, x squared minus 9 is a difference of squares, so that can be rewritten as x minus 3 times x plus 3, and then it's still times x plus 4 equal to 0. All right, now we set each term equal to 0, so x minus 3 equal to 0, x plus 3 equal to 0, and x equals, I'm sorry, not x equals, x plus 4 equal to 0. So x equals 3, x equals negative 3, and x equals negative 4. All right, go ahead and finish up your examples and start working on your assignment, and have a wonderful Wildcat